All right, ladies and gentlemen, we're talking about this chapter. The next chapter is basically about power and the conservation of energy. And we're going to take a look at this. And actually, the concept is fairly easy. It's the application that can be a little bit more difficult. So let me get my pen going. I'm going to remember to take notes on this. So what we know is the energy cannot, like matter, cannot be created or destroyed. We always convert it from one form to another. And this is what type of forms do we have? And we've got a lot of things. We've got electrical energy, we've got chemical, and so on and so forth. And we kind of lump these sums into mechanical and not mechanical energy. Now, mechanical energy is not only the sum of potential kinetic energy, it's what we think machines do to make work. And so when we talk about energy, and we're going to ignore friction with this, then ME, which is mechanical energy, remember this is mechanical, so we have an object with some mechanical energy, and we do something to it, it's going to have the mechanical energy does not change, just the form of it. So, and there's going to be three different ways we're going to write this. And folks, remember, you can substitute. Remember back in mathematics and algebra, we always did a lot of substitution. You're going to do the same thing here. So ME initial and ME final. This is my ME initial. This is my ME final. It's just a different way to write it. So this is MEI and MEF. So our initial kinetic energy of the object plus the final kinetic energy of the object is equal to the final kinetic energy of the final kinetic energy and the final potential. Now let me re-say that. Initial kinetic plus initial potential is equal to the final kinetic and the final potential. And here is the equation we'll be working with. 1/2 mv squared, this is kinetic, and this is initial, plus mgh, this is potential energy, and this is initial. And here's my final kinetic energy final. And this is my potential energy final, PE final. Now, realize that I can say that h can be some other distance above the ground. It doesn't have to be 0. And that's something we need to be aware of. I may do that to you, I may not. It depends. So on convention, for acceleration of gravity, always use positive value, please. And mainly because is that we want the kinetic energy to be positive. Potential energy to be positive. And when we talk about this, we've got to have a 0 point, and we're talking about things going up, having a positive potential energy. In this class, we will not have a negative distance. And that is for when you get into college. Now, when we talk about other forces like friction, air resistance, anything that's going against where we can lose energy, and we're basically lumping these together as loss energy. And here's the thing, folks. Some books have loss energy at the end as part of the sum. I like to have it as the final. So we have initial kinetic energy or initial potential energy, and kinetic energy 0 as it's traveling through. We're losing some of that energy to friction, and then we have, but it's added to the final. And this is the same equation we worked on initially, but this is what we're dealing with. And remember, when loss energy is just LE. I also want to point out is that if you're given total mechanical energy initially, that's this. So you can substitute K, PE, KE, and so forth. Sorry about that. Okay, let's go to this one. So what is power? Power is defined as the rate of work being performed. So power is equal to work divided by time. Or power is equal to the change in work over the change in time. And the unit for power is watt, named after James Watt. Now, remember, power is equal to work divided by time. Power that means it's work. Work is force times distance divided by time. Oh, look, power is equal to force times velocity, where velocity is distance divided by time. So realize we've got force times velocity. Power is equal to work divided by time, or power is equal to force times distance over time. Any of these three equations will work, and you need to make sure you understand how to get those equations for the test. All right, I'm going to stop here and give you a set of examples later. Have a nice day.